Hey folks, it's TT. I want to talk about another book that I read this week. This one is called The End of Everything. It's a brand new book by my favorite astrophysicist, Katie Mack. It's a book about an apocalypse of sorts, but this book has much bigger fish to fry than the end of the world. That is sort of a small footnote in the beginning, how the world itself will end. Eventually, a few billion years from now, long after humans are gone from the planet, our little blue planet will be swallowed up by our sun as it reaches its red giant stage. Bye-bye, see you later. This book is not about that, though. This book is about the end of the whole universe. Now, I am by no means a cosmologist, but I became kind of interested in Katie Mack's work last year when I heard her speak in a podcast. And since then, I've been following her on social media, and she's really funny and interesting. So I decided when I heard she had a book coming out that I had to pre-order it. I wasn't super confident that I was going to understand the book very well, given that I've only recently developed an interest in science and astrophysics. I really did understand it pretty well. There were definitely points when I had to reread a passage or Google something, but given that the subject matter is so far above what I'm really equipped to be reading about, I think that it shows that she does a really good job of writing in layman's terms, that I was never lost at any point. There was never a moment when I didn't understand what was going on, just moments when I felt like I wanted to understand better. So I wanted to go over 3 of my favorite theories that are posed in the book as to how the universe might end. Now, these theories are gone into in much greater depth, and the reasons why and the math behind it, all of that is in the book. I would really encourage you to check it out if you would like to better understand all the factors that go into these theories. So the first theory that I want to talk about is called the Big Crunch. The Big Crunch is basically the opposite of the Big Bang, and perhaps a natural consequence thereof. The Big Bang, as you may know, refers to the theory of how our universe began. Everything was compressed into a hot, dense state, and eventually it started to expand. And the universe is expanding even now. Scientists can tell that other celestial bodies are receding away from us using a scale called redshift and blueshift due to the shift in light frequency observed when an object is moving away from Earth or closer to it. So we've known for a long time that the universe is expanding. But what was more difficult to tell is if it was expanding at a slower rate than it had been in the past. If it was, that could mean some not so cool stuff for our universe. To borrow Mac's analogy, think of how a ball acts when you throw it in the air. The force of you pushing the ball into the air makes it move upward, but gravity pulls on it as well. And if your force isn't strong enough to literally throw the ball into orbit, eventually gravity will force it to slow down and change course. Now imagine that the Big Bang is just a kid throwing a ball in the air. That initial push that made everything expand out from that initial hot density could eventually reverse course and pull it all back together. That's what is referred to as the Big Crunch, because it all comes crunching back together. I think this theory is really interesting. It feels kind of nice and compact and cyclical, and it feels like very circle of life to me. But Mac does qualify that, according to more recent findings, this isn't really the most likely fate of the universe after all. That brings us to theory number 2, heat death. So it was kind of taken for granted that the universe's expansion was slowing down at some rate, just not for sure whether it was slowing down at a high enough rate to cause it to eventually reverse course. But findings in 1998 seem to indicate the totally mind-blowing possibility that the universe's expansion was not slowing down. It was speeding up. The reasons for this are really complicated, and if you'd like to understand them more, I would defer to Katie Mack's book. But for the purposes of our summary, just know that the universe's expansion was decelerating up until about 5 billion years ago when it started to accelerate instead. Awesome, right? Our universe is not going to squish back in on itself and crunch back up into a massive, heated, dense ball. Yay. Not yay. Not yay at all. What happens if our universe expands forever is kind of worse. As the universe expands, individual galaxies will become more and more isolated. There will be no nearby galaxies to exchange energy with. Eventually, even the black holes will decay. As Katie writes on page 96 of this book, every time a star burns out, or a particle decays, or a black hole evaporates, it converts more matter into free radiation, which spreads through the universe's heat. Pure, disordered energy. Reducing something to heat radiation is dialing up its entropy to the max, because there are now no restrictions on the flow of energy. When everything is reduced to nothing but radiation, the universe will be at a state of maximum entropy. When there's no way for entropy to go up, nothing else can happen. And that's heat death. So that brings me to the last theory that I want to talk about today, number 3, vacuum decay. I love this one. I think it's so creepy. To help us understand this theory, Mack teaches us about something called the Higgs field. Basically, the Higgs field is what gives some particles mass. Certain particles interact with the Higgs field and become massive, whereas others, like photons, don't really interact with the Higgs field, so they remain massless. By determining which particles in our universe have mass, the Higgs field basically determines the state of our physical world. The state in which we currently exist is called the Higgs vacuum. And to use Katie Mack's rather unsettling words, that vacuum is pretty unstable. The Higgs vacuum that we exist in has the potential to catastrophically change the laws of physics at any given moment. The theory posits that the state that we exist in now is really a false vacuum, that there is a much stabler state called the true vacuum that the Higgs field will eventually achieve. If the Higgs field were to move into the true vacuum, we would end up with a small bubble in space where the new laws of physics apply and particles behave completely differently. Mack refers to this as a bubble of quantum death, which is like the metalest thing I've ever heard in my life. That bubble would expand at the speed of light, and it would effectively disintegrate everything in its path before we could even see it coming. It could happen anytime. It could happen right now. We wouldn't even know until we were already dead and our planet destroyed. It would take a severely high energy event to trigger this though, so maybe don't lose sleep over it. Odds are this wouldn't happen for billions of years. Probably not until one of the more devastating theories was already well underway and we would welcome the quick, painless death of the vacuum decay. Those are just a few of the theories that Katie Mack goes over in this book. I really appreciated the superhuman way that she approaches everything. There was a lot of cold, hard science in the book, but it's all punctuated with a lot of humor, a lot of genuine emotion, like healthy, tiny doses of existentialism. There's a kind of healthy nihilism that sort of comes out of this for me. I guess I just feel like, why not ask that girl out to dinner if the ever-expanding universe is just slowly fizzling out anyway? But there is also that sort of bittersweetness of talking about the end of the universe that we live in. And I like that Mac doesn't ignore that. I like that she addresses the fact that we have a weird attachment to the universe, and even though none of these things are our problem, because they're all going to happen long after we're all dead, we still feel a little torn about how to feel about them. So those are just a few of my thoughts on the end of everything, astrophysically speaking. I will drop a link in the box, and also you should follow Katie Mack on Twitter at AstroKatie. She's really funny, and I think you'll find a lot of enrichment from her tweets. I know I do. I hope you learned something, and I am excited to keep making these videos. Have a few more books on my list that I'm hoping to get to by the end of the year. And I'll be posting my thoughts on those too. So if you want to follow what I've been up to, what I've been writing and reading, subscribe to this channel. And I will see you next time. Bye.